Well, good morning, everybody, and thanks for joining us on part 2 of Common Issues with Geothermal Heat Pumps. I want to take a moment to just thank you for your patience and your understanding in the abrupt rescheduling of last week's webinar. Thank you for attending today. We're going to go through a number of things, and this will, of course, be recorded and posted onto the cmdealernet.com website for your review later if you wish. So we're going to cover a number of things here. I'll try and be expeditious in there, and we will take questions toward the end. So you're welcome to type in questions. We'll take a look at them and get as many answered as we can. We're going to start out by discussing antifreeze. Why antifreeze in a closed-loop system? Well, if you're entering loop solution temperature will ever hit 40 degrees or perhaps below, then you're going to need to put antifreeze in there, because if it's entering at 40 degrees, it's going to be exiting somewhere around 6 to 8 degrees lower than that. You're tap dancing with a freezing condition. In the northern or heating dominant climates, your loop temperatures can reach from the mid-20s to around 30 degrees. And if that's the case where you're going to be applying this particular loop design, then you want to make sure that you're applying enough antifreeze to get your freeze protection down to about 15 degrees. Even if you're in the southern states, the southern exposed piping scenarios, in other words, if you are placing a unit on a rooftop, in an attic, in an exterior enclosure, where that environment will start to see some freezing conditions, you may want to put some antifreeze in. You don't necessarily have to get down to 15 degrees, but you want to make sure that you're protecting your heat exchanger and internal components of the heat pump. Once you've achieved a minimum level of 15 degrees, if you've applied that much freeze protection into your system, then you want to go ahead and cut that FP1, also labeled as JW3 jumper. That way you can make sure you realign the circuit board to where it can now operate at a lower temperature. And I will tell you, if you forget to do that in the first couple, 3 weeks of the heating season, you're going to get a phone call from your customer that they went out on a freeze protection fault because that entering water solution entered at about 40 degrees or so, and it tripped. It assumes with that jumper not cut that you are pumping raw water through it, and its trip point again is at 40 degrees entering. Antifreeze, one of the things that I've seen in my career is I go out to projects and a lot of guys have done the antifreeze additive by gosh and by golly. In other words, they just kind of threw some in there, didn't really calculate, and they typically over antifreeze is more than common than what I've seen. You can typically see it and smell it when you draw a sample. And that's not good either, because too much antifreeze can inhibit your temperature transfer. I've seen some automotive antifreeze use some of the ethylene glycols, which I do not recommend. Some of the additives they put in to protect the cooling system in an automobile will actually coat the heat exchanger and prevent much heat transfer. Too much antifreeze, especially the glycols, can be much more difficult to pump. They get viscous when it gets cold, and the specific gravity changes quite a little bit. So the other component I want to mention is that too much antifreeze, well, that adds to your cost. That takes out of your pocket. Some of this antifreeze is anywhere from $15 to $20 a gallon in its pure form. You don't want to put in more than you need to, but certainly not less than you need. Let's talk a little bit about too little antifreeze. Too little can jeopardize the coax integrity. In other words, if you start to swell and or freeze that heat exchanger, you're going to have performance issues. If you don't have enough antifreeze in there, as you tax your loop and that temperature in the solution drops, you can actually start to create what we call ice lancing. And that is ice particles building up. And they'll actually start to choke off or restrict the flow, which slows the flow rate down, which means you're going to ice up a little quicker because it's lingering longer with the refrigerant. And you could, in fact, get a freeze protection fault. Well, once that compressor shuts off and the unit sitting there, it's going to thaw out because you weren't fully frozen. You were just starting to build up ice crystals or ice particles in there. And what we see is that a guy goes out there and he does his testing and he blames the freeze protection sensor when in fact it probably wasn't the sensor. It was insufficient antifreeze. I see it quite often, actually. Freeze damage is never a warranty item. We did not send you a geothermal heat pump with a frozen heat exchanger. Damage could result in unit replacement. Good for ClimateMaster, not so good for the homeowner and the contractor who didn't put in enough freeze protection fluid. So it's important to make sure that you put in the appropriate amount and you verify that amount. Here's an example of a frozen heat exchanger. You can see in that cutaway, that center tube, the outer steel jacket and the inner copper fluted tube is, the inner copper tube is where the fluid flow is, and between that copper flutes and the steel jacket is where the refrigerant travels. Well, when you expand out, because you froze the heat exchanger, you expand out that copper, you're not going to get good refrigerant flow through your heat exchanger. But remember, you can't see it. It's all behind that steel encasement. So you will have performance issues. If you want to go ahead and submit a warranty claim for a frozen coax, I would never discourage you, but please print clearly, because when you send that in, we want to make sure that we post you on the wall of shame and we give you full credits. We want to make sure that we spell your name correctly. In our IOM, this is the three most commonly used antifreeze solutions: methanol, ethanol, both alcohol-based fluids, as well as the propylene glycol. You touch for a moment on the two alcohol fluids. Those are highly flammable. They're a bit volatile. So if you're going to be utilizing it in anything but an open carport, in other words, in some kind of a structure or enclosure area, please make sure that you cut it 50% with water to take that flammability away from it. Please always use eye protection as well. Differences between the methanol and ethanol. Methanol has slight toxicity. Ethanol does not. Again, the flammability is a concern. Make sure that you're using the appropriate amount, about 25% fluid by volume with the ethanol to get that 15 degrees, 21% with the methanol. The propylene glycol, again, not my first, second, third, or fourth choice, is a 25% mix as well. I don't personally care for propylene glycol because it is difficult to get enough fluid flow out in your ground loop to make sure that you have proper turbulence, so you have good capacity or full capacity out of your ground loop. Typically, in most systems, you're going to have to pump at least 4 gallons a minute through a glycol loop field to have a prayer head sneaking up on turbulent fluid flow, or Reynolds number of 2,500. You should always verify your antifreeze amount. In your screen here, you're going to see an example of a refractometer. They sell them for alcohol or glycol. It's not a universal. You need to purchase one or the other, or both, if you're going to be utilizing both kinds of fluids. These are nice. They're fairly small. They're fairly competitively priced, more durable than certainly the hydrometers. You simply put a drop of your sample fluid here. If you look on your screen, follow my cursor, you can see you'll lift up this cover. You'll put a sample via a eyedropper here on the screen. You'll close that lid, and then you have to have some pretty darn good light to be able to look through it, and you're going to see the indication on the BRIX scale, BRIX. That is how they're measuring that alcohol content or the glycol through the refractometer. Each one of these comes with a BRIX scale. On your screen now is a methanol BRIX scale, so that you can compare and convert what that BRIX number you saw through that viewfinder translated to in level of freeze protection. So that's an option for you. Another one that we use commonly in the industry is a hydrometer. You must have a cylinder that's tall so that the hydrometer can freely float. Does not necessarily need to be clear. You can use a piece of 1-inch PVC, for example. It needs to be at least 12 inches long, again, so it'll freely float. If it's a piece of PVC, for example, you're going to need to fully fill that cylinder so that when you drop your hydrometer in there, it will displace fluid, and you will then be able to read the scale at the fluid line. In this example, we have a alcohol hydrometer. You can see on the scale, the bottom of the scale near the bulb is 1.0. Going up to the top of the scale, it's at a 0.9. Again, you read the hydrometer at the water or solution level. This example, it's approximately 0.982-ish, somewhere in there. Again, reading that at the solution level. In our flow controller IOM, you're going to find the conversion tables for the specific gravity for ethanol, methanol, and propylene glycol. Please keep in mind that the hydrometer for the glycol is different than that used with the alcohol. So on that previous slide you saw we were approximately 0.982. And if you read over from 0.982 to that slope and then drop down, you're going to see that that solution has a freeze protection of probably somewhere around 12 or 13 degrees. So now you're good to go to cut that FP1 or JW3 jumper. What you want to do is make sure that when you cut that jumper, you kind of separate those wires. I've seen guys just snip it, and yet the wires are close enough together they actually kind of remake contact. So make sure you kind of separate them out a little bit, and please double check before and after you cut this jumper that you have cut the correct one. JW3, also known as FP1, that is the jumper you wish to cut on that CXM board. We're now going to kind of shift gears a little bit. I want to show you the website. And folks, this is your website. It's a website you should go to often. There's a terrific amount of information here, and it's a dynamic, ever-changing website. Again, this is your website for a lot of information and marketing trends and things of that nature that's available to you. So we're going to show you how to get to some of the things we're going to cover in this program. So you've seen here on the screen that we've highlighted the sales and technical literature. So we're going to select that. On our next screen, there's a menu on the right, and we're looking for charts and forms. Again, there's a lot of information available to you here on cmdealernet.com. That is your website. So we're going to select charts and forms. And we're looking for a startup and commissioning form. Well, this is a fairly new one that we posted here, and it's got some versatility. First of all, you can bring it up on your computer, and you can fill it in, fill in the fields online. It won't calculate anything, but it's something you can do out in the field. Please make sure you always print off a hard copy. It'd be nice to have one in your job jacket, probably leave one on the job site if at all possible. Or if you wish, you can actually just print this off at your home or your office and bring them out to the project with you. This is also going to end up in the IOM for the heat pumps and the IOMs throughout the product manual as well on the next printing. Next, I want to show you the training videos. You'll see on your screen we're selecting that. And under training videos, there's a menu off to the left. We're going to select troubleshooting and service. So select that. And you're going to see on your screen in front of you, again, this is a picture of the website, and it's going to show the a number of DXM2, our new digital controls, some of those fault codes, flushing, as well as ClimaDry flushing, which we're going to talk about a little bit later. But in particular, I've got the arrow pointing to the water side analysis procedure. If you're not familiar with how to do and calculate and perform heat of extraction and heat of rejection, we don't really have the time to cover that this morning, but there is a step-by-step video available for you here. It shows you exactly how to do it. And I encourage you, if you haven't done this before, you want to play this video. Again, available to you 24/7. So when you're going to go ahead and approach a unit that's got some kind of issues, the first thing you want to do, in my opinion, is obviously check the filter. And remember, the homeowner changes that filter as you were driving out to the job site. Just go look at the garbage, by the garbage can. You typically find that throw rug, which used to be filtered. But I want you to operate that unit for at least 15 minutes. And as a reminder, if it is a 2-speed heat pump, it always needs to be in high speed. Why 2? You need that thing running full tilt boogie. Heating or cooling, whichever mode you wish, always disable the hot water generator. You do not want that influence applied here. A couple of precautions here, folks. This is something that we see out on the road when we go out to project sites. We see guys that show up and they tend to get in a hurry. You do not want to start taking your readings until everything has had that 15-minute minimum run time to get to a steady temperature, as well as refrigerant pressures. And let me give you a couple of examples. If you rush to take these readings, you're not going to likely get a representative condition of the air, because most of these systems are air, forced air systems. You won't get a real representation of what the air in that home truly is. The other area of concern is you want to make sure that that loop fluid has a chance to blend and circulate, and you're actually getting a true representation of what the loop fluid temperatures are, because those are what you want to check. What is the conditions that caused this fault or whatever brought you out there? Also make sure that you bring a good quality large dial pressure gauge. It's good to have two, but only use one. Leave the spare one in the truck always. Okay, make sure it has a good PT needle on it. I highly recommend you have a couple of good quality digital temperature gauges, but again, keep one in the truck, only use one. Don't use two ever. You could run into calibration issues, and if your calibration is too far off between the two different instruments, you could chase a problem that perhaps didn't exist or miss a problem that did exist. So please heed my warnings and do it right. Remember, you only get a couple swings at the plate before the homeowner goes somewhere else. So be that professional. Reap the rewards of those referrals. I'm not going to cover all of this, but here's your basic formula for calculating your heat of rejection or heat of extraction. So it's temperature difference, or delta T, times your flow rate, times your fluid factor. The fluid factor for water is 500. If it is other than water, it is 485. To determine gallons per minute, you have to convert from your pressure difference to gallons per minute. Again, we're not going to cover that at this point. We're going to reference that in the video. Or reach out to your tech rep at your distributor level. They can show you how to do this. So that is your formula. One of the things you can do while you're waiting for that 15-minute runtime is on the hot water generator / CFM or ECM blower board. Anytime that fan is operating, that amber light that's circled there, every time it blinks equals 100 CFM. Well, you need to know the CFM when you're doing water side analysis, so go ahead and count the CFM, because that doesn't need to wait 15 minutes, and it kind of kills the time that you're spending there anyway. So count those blinks and write that down, and then I strongly recommend you reference the product technical guides to make sure that that is within the CFM range that it needs to be for that unit. If you need to adjust that, or even if you have the dehumidification dip switch set and you saw that light lit up, you need to take it out of that mode for this test. So if you need to change that fan speed or take it out of the dehumidification mode, remember, before it will notice and secure that new CFM range that you just selected, you have to power the unit down for at least 3 seconds before it will pick up that fan speed change. So make sure that you do that. It's an important part, and you can't miss it. Here's an example of the commissioning worksheet that I showed you on the website. Again, the blue areas you're seeing on your screen is something you can now fill in on your laptop, or you can just simply print it out, fill it out in the field. And I highly recommend that you do fill out these areas. Put that customer's name in. That date's important. The antifreeze, in this case, this example, it's an open loop. We're just using water. Critically important, you always put the model and serial number there. Again, it's nice to have the reference for this unit. So, for example, this form, in my opinion, can be the commissioning or startup form, should be, as well as it can be also a troubleshooting form initially when you go out to see what's going on, even if it's just routine maintenance. Always perform this. Take the voltage, make note of the amps draw, make note of the wire size serving it. So you're going to see in this example, you have boxes near the air coil that you can check so that you can reference, look, I checked this in the heating or in the cooling cycle. In this case, just above the coax, behind the air coil, we have a place where you can record your CFM. Remember, you counted 1 blink per 100 CFM. Next, you want to put in your entering and exiting fluid temperatures. So probe your digital thermometer into the PT ports and record those temperatures. Again, after that minimum 15-minute runtime, full tilt, Y2, high speed if it's a 2-speed. and the hot water generator has been disabled. So in this case, we have an entering fluid temperature of 53. It is exiting at 50. Next, you're going to probe in, and it doesn't matter which order you do this, your pressure gauge. Again, needs to be a large dial, 3.5-inch dial face, so you can see the movement in the needle. In this case, we're showing a 46 psi entering and exiting at 43. So we have a 3 psi pressure drop. When you go to the reference tables, again illustrated in the water side analysis video, you will find that that equals, on this particular TTS, which is a single speed, 048, 4-ton, this translates to about 9 gallons a minute. Now this unit is open loop. It's using the raw water. Open loop, we can use about 2 gallons per minute per ton. This unit needs about 8 GPM. It's pumping 9. It's probably okay. So at the very bottom of the page, guys, you'll notice that we're going to finish up our formula here. So we're going to put our flow rate in there of 9, then our temperature difference of 3, the fluid factor of 500. We're going to calculate that out. Again, it shows you at the bottom of this page, use 500 for water, 485 for other than water, in other words, antifreeze. In this case, we're drawing out or extracting 13,500 BTUs, which is low. So let's talk about what this is showing us. You got a couple of choices here, and let me give you my strong recommendations. Because this is open loop, we have sufficient fluid flow, we have good airflow, and we're just not transferring the temperature through the heat pump. It's not necessarily a refrigeration issue, and in fact on open loop it probably isn't. My next step, based on the information that I see here, is that I would probably go get my 5 to 8 gallon bucket, my self-priming pump, and a couple of hoses, and I would isolate the well water system, and I would flush out that coax. What is likely going on here is you've coated the heat exchanger with some of the mineral deposits or whatever happens to be in that well water, and it's no longer transferring the BTU as it once did. If you did a performance startup sheet, you may have some comparisons. I always did that. I made sure I did a startup sheet. That was part of my job folder. Sometimes I left it on the job site with the paperwork of the heat pump so that I could tell what it once was and compare it to now. So again, I'm going to bring out that bucket and those hoses and that pump, and I'm going to circulate that cleaning solution through the coax. What is it that we use? Well, whatever we use needs to be non-toxic. It needs to be little to no acidic content. A lot of times what's used is the products used to clean ice machines. Nickel Save is one particular brand. There's a number of them out there. I know that people use vinegar. I know that some people use the product CLR. Again, non-toxic. It needs to scrub and scrub it back down to metal and dislodge all the mineral deposits and do it safely. Again, once you've accomplished that, go ahead and run this same test again and see where that information leads you. And in most cases, that's probably going to turn it around. So that's what I would do first. Again, as always, the last thing I would do is bring out my refrigerant manifolds. That's DEFCON 4, and you're nowhere near that. So again, if you see this on an open loop system, that's going to be what I would say is your appropriate next step. All the other items seem to be in line. It's just that temperature difference through the coax. Our next example here is a 2-speed 049. This one has a little bit of a heavy methanol solution. This one is checked in cooling, so let's take a look here. We have an entering water or fluid temperature of 89 degrees, and it's exiting at 104. So we're getting about a 15-degree temperature rise. We have a PSI entering of 23, and it's exiting at 21. Well, if you convert that pressure difference, again on the tables in your IOM, you're going to find that the flow rate's just about 8 gallons per minute. On a closed loop system, because this has methanol in it, you want about 3 GPM per ton. So this one's a bit on the low side, which would explain the 15-degree temperature difference going through that coax. You have typical flow rate of 3 GPM per ton. You have your typical 400 CFM per ton for the airflow. You should see on average is pretty common to see around a 10-degree difference on cooling. So when you see the 15-degree rise, that typically means you have too low loop flow. Well, what are we going to do? My recommendation is this likely has 2 pumps on it. If you got 2 pumps on it, I would do an amp straw on each pump, and I would compare that amp straw to the electrical tag on the end of the pump. I'll show you a couple of pictures here coming up. My guess is you may find that you've lost a pump. One of the things that I know that some guys do is they will remove the screw off the back of that Grundfos pump and insert their finger, and oh yeah, it's working, because they can feel the end of the shaft turning. That is not a good test, guys. You always do the amp straw, because that'll show if the pump is actually working hard or not. I have seen too many cases where the pumps have actually snapped the impeller off the end of the shaft. So by sticking your finger in the end of where that screw is, yeah, the shaft's turning, but it's doing nothing. The amp straw will in fact show if that pump is under a load or not. So that's probably the direction I would go, is I would start to see, do I have the pump or pumps in line? Are they operating appropriately? Take those corrective actions that shows you, and then start to start this process over. Take these test readings again. You never know. You may find that someone put a valve in somewhere and it could be closed. So start to see where the fluid flow interruption is and make that correction, retest. Our next example here is an 038 2-speed. This one has a more appropriate methanol concentration of about 21%. This is in the heating mode, and let's see where this one takes us. So we have the 1200 CFM, that's good, 400 CFM per ton. We have an entering fluid temperature of 31.4. It is exiting at 28.2, so that's about a 3-degree difference. Our pressure difference, so we have 45 psi entering and 37 exiting. Well, I can tell you that that large pressure difference is pretty much off the charts for our flow rate. If I was to extrapolate or interpolate, probably 11.5 or so GPM. Well, I'm not going to tell you should go ahead and kind of interpolate, because, well, you're going to be off the charts anyway by calculating this heat of extraction. Well, what are we going to do here? Well, this could be one of those. I've seen many out there because of installers that install by rule of thumb. They may have put 2 flow controllers or 2-pump flow controller on this particular 3-ton unit. So I would recommend you power the system down, disconnect the power to one of those 2 pumps, again, after you powered it down so you can do it safely. Power the unit back up and see if that is what all you needed to do. See if that makes it fall in line so you can at least do your test. Now, in all fairness, some folks may put 2 pumps on there because perhaps, in this case, we know it's methanol, but if the installer was using the propylene glycol, remember, they have to get upwards of 4 GPM per ton to try and get turbulence out in the loop field. So that could be why they have the 2 pumps, so that they can deliver that kind of flow rate, but it doesn't help you for your test. So if that's the case, go ahead and disconnect the power to 1 pump, do your analysis to make sure the heat of extraction or heat of rejection, whatever mode you're in, falls within the performance tables of our IOM, and then once you're completed, go ahead and reconnect the power to that pump. But again, that's typically on a glycol loop. So again, folks, I want to really emphasize, I want you to go to the easy fixes first. For example, if you see that CFM is off, you may want to consider, going around the house. If you're, if you have the settings correct on your fan control, then you may want to take a look at dirty filters. Maybe the homeowners have shut off enough heat vents that's inhibiting it. But again, you typically will hear that in the ECM because it'll be working pretty hard. It'll be over-ramped. I mentioned earlier, if you wanted to determine if the ground loop pump was appropriately drawing enough amps, here's an example that we took. This pump is operating and it's drawing about 0.94 amps. Well, here's the electrical rating of the typical Grundfos 26-99 pumps. Its specification shows about 1.07 amps, so the 0.94 is awfully close, and that shows that that pump is actually under load. Again, that's a good appropriate test when you want to test a pump to determine, is it operating, is it delivering the goods? Because you can't see what's going on inside. This is a good test. Kind of moving along, guys, we're going to talk about, on a pressurized system, what if air is still in the loop? Well, sometimes you have the luxury of actually hearing it. Perhaps that's the reason why the homeowner called you out there, as they heard gurgling or they heard the pump rattling when the air pockets came through it. But there's some easy and simple things you can do to determine if perhaps you still have captive air in that loop. Because I want to remind you that if air remains in a pressurized closed-loop system, it will simulate for a leak forever. So what are you going to need? Well, you need that, again, large dial pressure gauge. Bring only one to the heat pump with that PT needle attached. You're going to need your bump up, or alternately called a loop looser tool. And then you're going to need a small container to draw some fluid sample into. Here's an example that you can do. So with the unit powered off, so the pumps are not operating, and it doesn't matter, whatever works best for that configuration, whether the bump up tool is in the upper PT port and the pressure gauge is in the bottom one. If the unit's sitting on a floor or an air pad, you probably will need to do that. You'll see why in a moment. It really doesn't matter which one goes where, whichever one works out best for what you're trying to do here. So you insert that large dial pressure gauge and that bump up tool each into a PT port, again with the pumps off, so power that unit off, and I want you to write down, I want you to record that static pressure. You see this one is almost 38 psi. Next, I want you to take a relatively modest sized cup, not one of these truck stop big boy commuter mugs. You know, about 6-8 ounces, okay? I want you to draw that kind of solution, again, with the pump turned off. Draw that cup of solution and then note, by writing down, record that lowered pressure. You can see here that we dropped almost, well, 9 to 10 psi by drawing just that small amount of fluid. And since I've drawn that fluid out of that system, you know what? I'm going to go ahead and drop a little bit on my refractometer, or if there's enough fluid there, I might try and pull up my hydrometer just to test the antifreeze level if it had antifreeze in it. Next, I want you to be patient and just watch the needle. It could take 10 up to 20 minutes, and spend the 20 minutes if necessary and watch the needle. If that needle starts to climb, that typically means you have air still in the system, because remember, air and gases compress, liquids do not. So that is another way of a simple test to determine if you have bound air or captive air in that system. And if you do, you're going to have pump problems, performance problems. It'll be noisy. You could eat a pump, maybe two. But also you could have a loop out there that is airbound, which means it is not contributing heating or cooling. So it's time to bring out the appropriate flush cart and follow those flushing procedures. Where will you find those flushing procedures? cmdealernet.com. There's about a 40-minute step-by-step video, including, guys, it also shows what are the components that make up an appropriate flush cart. Moving along now, this section will cover the CXM residential control. We are not going to cover our new digital DXM2. There's too much to cover in this short of a segment, so we're going to cover the stalwart board we've had out there in our product line for some years, how to pull the fault codes off that CXM board. We're going to cover thermistor diagnostics and replacement, and then what to do when you get the fault code information. So here's an example of the CXM board in the typical residential product line. You're going to see number 1 circled there. That is your test pins. Item number 2 circled on your screen there. That is the LED status light. That lets you know whether the system has a call or it's operating, or if it has a fault in memory. Please, guys, never, ever, ever send a homeowner with a butter knife or a screwdriver or anything else anywhere near this circuit board. okay? Only for your eyes and your tools only. You're going to see on the bottom of this screen, you're going to see the menu. What do the fault codes or the blinks mean? And that is adhered to the inside cover of your electrical control box in that heat pump. So to enter the test mode, to pull those faults, you can jump across those test pins, that number 1 that you just saw circled, for 3 seconds. That fault status light will go out. There will be a pregnant pause for a couple moments, and then it will start to blink the pattern. Give a pause and blink that pattern again. It'll continue to do that as long as it's in that test mode for up to 20 minutes. Or the same exact way to also access that information is to cycle the fan switch on the thermostat 3 times within 60 seconds. That is the same thing as jumping those test pins. If you wanted a homeowner to go ahead and count the blinks, or more importantly, let him listen to the alarm relay clicks without taking the door off the cabinet, you can have them cycle that fan switch 3 times within 60 seconds. Have them listen for the clicks and tell you what that is. That might allow you to show up a little more prepared if you're comfortable with that. The other thing this does is that it speeds up our time delays by 15 times, so you can hurry up and get back onto that compressor cycle. Remember, we have about a 15% bleed by on our TXV, so it doesn't take but a couple minutes for you to get equalization on your refrigerant pressures. So again, back in the CXM section of your All Products and Technical Guide, you're going to see, and it's about page 500-ish. It moves around a little bit, guys, so please don't quote me the page number. Every time we print, we've added pages to our IOMs. It moves the page number around. But you're going to see that exact same fault code menu that was on the inside cover of the control panel. This is just a little bit easier for those of us that are advancing in age to read. So again, for example, if you counted a flash code 6, in other words, it's flashing 6 blinks, it pauses, and it flashes 6 blinks again. CO, fault in memory, that's condensate overflow. That's kind of how you translate what that information is from the CXM board. One of the other things we see very commonly is we see guys go out and they had a freeze protection fault, and their fluid doesn't show that it was actually in that temperature. Remember, we talked about ice lancing. Well, a lot of guys, what they'll do is they'll condemn the thermistor and they'll throw a new thermistor at it. Well, some of the thermistors we get back, and I'm going to say the vast majority, probably single-digit percentage that we get back, are actually defective. What does that mean? Guys didn't actually fix the problem. They threw a part, guessing. Okay? Please don't be that technician. Be that professional. Do it right. So, how do you do that? Well, if you suspect a thermistor, you want to take your attachable temperature display thermistor from a Fluke or whatever kind of a digital meter you have. You want to attach it firmly onto that copper tubing right next to that thermistor. You can see here on the screen that example. We have that attached right next to where the thermistor is. Next, you want to run that system. Again, give it that good 15 minutes of runtime, see what's going on there, and when it starts to stabilize, go ahead and record that temperature. So we're showing that thermistor temperature from our digital clamp on to be 71.2 degrees. Next, you want to remove the Molex plug so you can get access to the ends of the thermistors. Please do not even attempt to take an ohms resistance reading with these still connected to the circuit board. You will have interference from the board. You will not get a reliable ohms resistance reading. So we're going to go ahead and remove this Molex plug. Here's an example. You can see the FP2 as well as the FP1, now called LT1, LT2, thermistor locations with their colors and whatnot. So here's where I disconnected that Molex plug, turned it over and around so I can get access to it, making sure that I paired up the correct sensor leads, and I inserted the ends of my test leads onto those terminals with that corresponding thermistor. What I'm doing is I'm taking an ohms resistance reading, and in this example it showed it to be about 11.07 ohms resistance. Remember, there is no voltage involved. This is all ohms resistance being measured and calculated. Well, again, in that same vicinity, as I just mentioned, that menu for the fault codes, back in the CXM IOM section, Installation, Operation, and Maintenance, you're going to find a thermal resistance, ohm resistance chart. In other words, you can convert from ohm resistance to temperature. So you're going to see here, we have circled near the bottom of your screen, we circled the, well, 10.92 and the 11.42 ohms resistance, because we're kind of in between those two with our 11.07. And again, if you look at that chart over on the left-hand side in the temperature column, somewhere around 71.6 to 73.4 is the general vicinity of that temperature. And if you look on the right-hand side of our picture, we had a 71.2 degree reading. And I will tell you, for a thermistor, that's plenty accurate enough. That shows that it's right in the range it needs to be. If you want to double check, if you still have some concerns, you may want to consider doing an ice bath, disconnecting that thermistor and dropping it into a glass of water with ice, and give it another temperature range check, again using additionally your Fluke or other multimeter measuring device, and do it in a different temperature range. So that's thoroughly testing the thermistor to make sure that that indeed is the issue. Now, guys, I will tell you that with our new digital controls, but also with the CXM2 base product, anytime you're going to replace a thermistor, one of the things you now need to carry with you is a heat transfer or thermal conductive compound or paste. Okay? It's readily available at many distributors. That would include Johnstone Supply, a lot of the electronics distributors or stores, they will carry a heat transfer compound. You want to make sure that you're applying that to the thermistor and the area that you're attaching the thermistor with or on, so that you're making sure that that product helps you transfer the temperature so that that thermistor can soak out, giving you the proper amount of ohms resistance representative to the temperature. And guys, please use those clips. Those are stainless steel clips that firmly hold the thermistor in contact with the pipe. I do not recommend that you use zip ties in lieu of that. I don't mind if you put a zip tie over the top of the clip afterwards, but please don't skip that spring clip in favor of even a hose clamp or a zip tie. Or a twisty. I've seen guys use that too. So here's an example of the thermal conductive compound having been applied and then the clip attached to the copper tubing. Again, showing that we have good firm contact with that thermistor to the tubing, and we've used the heat transfer paste or the thermal conductive compound. Again, that's critically important. Again, make sure you insulate and cover that replacement thermistor, or even after you've made that test, make sure you wrap it well so it's getting good temperatures that we're trying to read, not influenced by the proximity to the compressor in the cabinet. Again, in that same vicinity, we just referenced that ohms resistance chart, guys. There's a menu here of the fault codes on the left, what they mean, and if you look, there is a heating or cooling, whichever mode you're in, then it tells you what the possible causes could be, and if you look to the right of each one of those fault codes, you're going to see possible solutions. Guys, this is critically important that you have your All Products Technical Guide with you to make sure that you have the ability to see this. Is this product, or excuse me, is this a manual available online? Yes, it is, but it's a pretty sizable download. So unless you already have it on your laptop, your iPad, or whatever you happen to be using out in the field, it can be a while getting it downloaded on your electronic device. So having that book in the truck, well, it doesn't require an internet connection or batteries. So again, guys, this will help you be that professional and start to steer you in the direction of, okay, now I have the fault code, what do I do next? What could have caused it, and then what are some of those remedies? This will help you start to define what you should be doing based upon the information you have garnered. And just to answer your question, Kevin, I have no idea if thermal supply carries that thermal conductive compound, but you should. Again, guys, back be the following page in that CXM IOM section, you're going to see some other areas that I bet a lot of you didn't know were available to you. For example, on the left, here's some of those issues. Unit short cycles, or only the fan runs, only the compressor runs, or the unit doesn't operate in cooling. So again, whether you're in the heating or cooling mode, you see that checkbox, possible cause with the solutions over to the right. So again, guys, having that book with you and having access to this material really helps you become a better technician, walking through, starting to eliminate the possibilities. So again, if you need to actually, if these remedies don't help you solve the issue, at least when you finally get a hold of your tech rep at your distributor level, they can help guide you through, because you've eliminated a lot of these other potentialities already. But you got to know where to find this information. That's why we're covering that. Here's another one for performance troubleshooting. Again, same vicinity in your all products technical guide. So insufficient capacity, not cooling or heating. Gosh, I see that all the time. First thing you want to do is make sure that that unit is delivering all the goods. So that heat of extraction, heat of rejection is always first and foremost. If that loop is performing, if the heat pump is producing all the BTU, either rejecting or extracting, heating or cooling, and that CFM is delivering out in the space, well, it can only be a couple things left. If the heat pump's delivering everything it can, well, either your ductwork doesn't have the ability to deliver it. We covered that in part one of this webinar. Could be that the load of the house is insufficient, or the unit was undersized. So typically it's a delivery or a load issue in that project. So that's typically what I see. But again, guys, here is a menu of possible causes as well as possible solutions. So having this available to you will make you a better technician. Again, if you need to call in and get some additional help, you can say, this is what I've done so far. And that will make it more expeditious for you and for your technical service assistant, or whoever's helping you. Now I'm going to cover a little bit of the ClimaDry. ClimaDry was our whole house dehumidification, not so much out in the Northwest, certainly something that we see down the South and Midwest, a little up in the Northeast where they have higher temperatures and more humidity. One of the common issues and complaints that we get is, you know, this thing is really delivering a high bill. And most of the time we find this is the cause. The owners typically have set the humidity level too low. In other words, they're trying to drive it too dry. You want to start at probably around a 50% humidity level and then make minor adjustments from there. Again, this is all about the comfort. You don't want it to drive you into the poorhouse. The other area is don't set the cooling temperature at or below 72 degrees. Remember, as you start to take the humidity out of that indoor air, the comfort is going to change, and you'll start to raise that cooling set point temperature because you now have a more comfortable and less humid environment. The lower the settings are, the more runtime, and the runtime on that heat pump means the higher their bill. Remember, you want this to meet their expectations of energy savings and comfort. So if you get a high bill complaint and it's involving a ClimaDry, one of the first things I want to ask them is, what are your settings? Both humidity as well as your cooling. Another one we oftentimes get is it's overcooling the home. It's usually caused from the humidity controls either not being wired up correctly or set up correctly. Sometimes not being operated correctly. You also want to check those dip switch settings per the IOM for that ClimaDry. As a test, you want to make certain that that internal loop pump is operating in the ClimaDry mode. Again, how do we do that? We take an amp straw on that particular Grundfos pump. Remember, it only operates when it's in the ClimaDry mode. That is also when the modulating internal valve should be operating. It's a very slow-moving valve that modulates and opens up when you're in the ClimaDry mode, which means you're basically air conditioning, but you're shoving some of that warmed loop fluid back up into that reheat coil to keep the air neutral going back into the home. So you want to make sure that that modulating valve is operating correctly. The other area that we oftentimes see if it's an overcooling situation is that the reheat coil is airbound. Basically, guys, it's a water-to-air coil. It's right behind the DX coil near the fan. It is frequently not purged properly, and that is not something that the loop pumps or that onboard ClimaDry pump will have any prayer of removing the air from. It must be used with a proper flush cart. You must follow the procedures outlined in the ClimaDry IOM. With that being said, I also want to state here that ClimateMaster does not recommend the use of non-pressurized loop systems on ClimaDry. We have seen that to be an issue on a number of projects. We don't see it as a very good fit. Again, only on the ClimaDry. Beyond that, if you want to use non-pressurized, that's certainly a choice you can make, but just not on that ClimaDry. We've seen too many issues with it. You must use a suitable flush cart and follow the detailed procedures in the ClimaDry IOM and or the video at that website we referenced earlier, and follow those procedures to make sure that you take the steps necessary to void the air out of that reheat coil. One of those steps that you'll see in the video, guys, and it's also referenced in the IOM, use the 2 air bleed ports that are installed on the reheat coil. So typically they're in a high and a low corner. It's about a 1/4 or 3/8 inch diameter copper tube that's coiled up. You can actually carefully kind of unwind that, get it out to where it's more convenient to work on it. Use a screwdriver to open it up to bleed the air out while you're flushing under high pressure. In other words, you're almost deadheading your flush cart, creating a lot of pressure with the modulating valve directing all the flow up into that reheat coil. Guys miss that, and boy, if you have an airbound reheat coil, you're going to have complaints because it can't do what it's supposed to do, so it's over air conditioning the home. Typically not very comfortable. It's not only cold, but now it's clammy because you're not pulling enough moisture out of the air. Again, depending upon your project location. So that concludes this section. Guys, I apologize. We're going to not cover the water-to-water because we just ran out of time with the slides we put together. We'll cover that in a future presentation of common issues. We're available now to take questions. If you want to type questions up here in the appropriate spot, we'll try and get those answered. If you have other areas you'd like to see us consider for future webinars, please type that in there as well. And hope you found this helpful. Again, we're going to try and do these quarterly in most cases. You never know if it'll be exactly every quarter. All right, what are some indications of a short loop field? Short loop field, typically you're going to see indications of high flow, and you're going to see a typically pretty rapid temperature impact. In other words, in the cooling mode, you'll see a rise in that loop temperature pretty quickly, or in the heating mode, a drop very rapidly. So that is typically a shortened loop or an insufficient loop. Sometimes that means that it wasn't properly headered and you don't have all the circuits participating. I've seen guys that actually take the same circuit and plug it into the same header. So you basically have a dead circuit, which means you probably have done it twice. So I've seen that also kind of illustrate the short loop scenario. This, I'm not sure which segment they're going to post whether it was the first one I did earlier before most of you were out of bed this morning, this same webinar, if that one's going to be posted on the CM DealerNet website, or it's this one. I don't know yet which one they're going to put in or post. And I don't know if it'll be today or tomorrow, but relatively soon it'll get posted up there. So you can review this. Well, since I have you captive, is this an acceptable format to give this kind of information out to you guys? Does this work well for you? We're trying to reach the masses and keep the material fresh. Seemed like a good choice, but we're always interested in a little bit of feedback. Yeah, the question that I'm looking at here is, do you recommend using a primary, secondary piping system or scenario when using high flow rates through the loop field, like glycol system, for example? We're actually going to cover that, and we're designing right now a round loop design module. You can certainly do a primary, secondary. Another option is to use a hydraulic separator, both that would allow you to drive that higher flow rate through the loop field and yet drive a lower and more acceptable fluid flow through the heat pump. One of the precautions, guys, you don't ever want to exceed about 5 GPM through your coaxial heat exchanger, because you can cause erosion of that copper heat exchanger and shorten the life of the heat pump. Again, that's not going to be covered under warranty. So I hope that answers the question. Well, guys, to be respectful of your time, I'm going to bring this to a conclusion. We're just about out of time. We've got about 2 minutes left, so unless there's a really, really quick question, I'm going to start to bring this to a conclusion. Again, I hope you found this helpful. Thank you for joining us. I want to take another moment to, again, apologize for having to reschedule from last week. I do appreciate your understanding. And let's see here.